Okay, so kind of going back a little bit to implicit. So implicit differentiation is when we have x's and y's kind of married together, right? But we can't separate, we can't solve for y like we usually do. Okay? So when we have that, and when we find derivatives, each y gets a little tag, right? Anytime we find derivative of a y, it gets a little tag. dy over dx. That's essentially the new stuff. That's essentially what's new. Everything else is the same rules that you guys have been doing for, this is the third chapter we've done derivatives. Okay? So number 6, let's start with number 6. Okay? So number 6 is a square root. Okay? So if we're finding derivatives, right? And we see a root, what have we always done in the past? What is the pre-step or a step we've always done in the past if we have a root? Change it to a power, because then we can use power rule or chain rule, right? So that's the first thing. Very, very first thing is change it to a power. So I'm going to rewrite this. So x plus 2y to the 1/2 power equals 5y. That's still chain. That's there's nothing. That's still what we do. Okay, and that hasn't changed. Now we find the derivative, right? So this side over here, to find derivative of this guy, we got to use chain rule. Okay? So move the power to the front. Everything on the inside stays. Subtract 1 from the power. Then we do a chain. Then we take derivative of the inside. The derivative of the inside is 1 plus 2 dy over dx. dy over dx, because 2 has a y. Okay? Equals, and then over here we have 5. The derivative of 5y is just 5, but it gets a tag dy dx because it's a y. Okay? All right, so now what we got to do is look at it, and we have to set those, we have to isolate the variable. We got to isolate that guy. There's a couple different things to do, right? We have a negative exponent. We got a fraction out here. So what I'm going to do is I'm going to kind of simplify, not really simplify it. I'm going to get rid of the negative exponent. Okay? So negative exponent means move to the bottom. Okay. The 2 is going to move with it. The 1 is going to stay on top. And then this guy is going to stay up here as well. Okay. So the question is, how do I get these guys, A on the same side and B by themselves? Mm-hmm. So we can multiply both sides by the denominator, right? So the only one that has a denominator is this guy. So we can multiply this guy here. That works. Let's see if this works. Multiply. Right? That goes away. That goes away. We don't really need that 1 in front. This 1 up here, we don't really need it, so I'm not going to write it anymore. So we have 1 plus 2 dy dx. No more over. Oops, not 2x. X plus 2y. Here's a question. Can I multiply the 5 and the 2 to make 10? Can I multiply the 5 and the 2 to make 10? That's my question. Think about that for a second. No, why not? So they are. So my question is if they're one term or two terms, right? If they're one term, if they're all one term, I can multiply anything I want inside. If they're two terms, if I break them up like that, could I multiply? The answer is I could. I can multiply these two guys because it really is 5 times dy dx because dy dx is the derivative. So it really is 5 times 2, which is 10. So I can do that. Okay, so I get 10 dy dx 1 plus 2 dy dx. Okay, so I got 1 over here and 1 over here. So again, now we've left calculus a while ago. We've left calculus after this step right here. No more calculus. We're not. This is just trying to isolate the variable. Algebra. How do we do it? Yeah. So get the dy dx over here, and then they both have a dy dx, right? I like that. Let's do that. Okay, so that goes away. We got 1 equals 10 dy dx root x plus 2y minus 2 dy dx. So now on the right side, how many terms do we have? On the right side of the equal sign, how many terms do we have? 2, right? We have 2 terms. We got this guy here, and we got this guy here. And they both have, actually they have more than more than dy dx in common, right? We can divide them both by 2 dy dx, but I'm not going to worry about that right now. I just want to get dy dx by itself. So I'm just going to have dy dx if need be, I'll factor later. I'm not really worried about factoring anything other than dy dx right now. Last step, divide by what you don't want. So we get dy dx equals 1 over 10 x plus 2y minus 2. Okay. All right. So like I said, The hard part about these guys isn't necessarily the calculus part. The calculus part we were done with a long time ago. It's isolating the variable. That's the part that's going to take you the longest and be the most difficult, right? It's not even the calculus part because you guys have been using those rules for a while. Okay. Okay, so let's look at number 7. Now. So it gives us an implicit equation, and then it says, then find the equations of all tangent lines to the curve when x equals 1. Okay, find the equation of all tangent lines to the curve. Okay, so our answer is going to look like this, right? Because it says equations of all tangent lines when x equals 1. So what's the first thing we got to do? So find the derivative. Okay, so that's what I got. Found the derivative of negative xy squared. Use the product rule. Got this. And then the derivative of 5x is just 5, and the derivative of 1 is just 0. So let me clean it up a little bit. Negative 2x dy dx minus y squared plus 5 equals 0. Okay. Then what do? What's the next step in finding the equation of a tangent line? Usually, I'm not talking about this problem, just usually, like you guys have seen this for like 2 chapters in a row. Oh, yeah, sorry, I forgot to put that. Yeah, you're right. It's supposed to be 2y, so there should be a y there. Yep. Okay, so what do we do after we find the derivative to find the equation of the tangent line? What's the next step always? Plug in the value for x. Now, this is the nice thing about these types of questions. We don't have to solve for dy dx right now. We can do that later. You can do it now, or you can do it later. You can solve for dy dx now, like we've been doing, or you can do it after you plug in 1. It doesn't matter. Okay? It doesn't matter. So let's plug in 1 and see what we get. Anywhere I see an x, I'm going to plug in a 1. So I get negative 2y dy dx minus equals 0. What else do I need that I'm missing? Actually, you know what? Let's solve for dy dx. Let's solve for dy dx now. I don't think we're ready for that question yet. Let's solve for dy dx. So I'm going to subtract 5. I'm going to add y squared to both sides. So I get negative 2 dy dx equals y squared minus 5. divide by negative 2. Okay, that's the derivative. So far, right, my answer's got to be this guy. So far, all I have is a 1 here. That's all I have. I need an m and I need a y1. How do I get m? How do I get y1? If I could plug those guys in, I'd be done with this question. How do I get m or how do I get y1? Either one. Because this is going to be my final answer here. But it's not quite done yet. So my question to you is, how do I get either y1 or m? How do we usually get slope of a tangent line? How do we usually get slope of a tangent line? How do we usually do that? Find the derivative and then do what? Plug in x, right? Plug in x. Well, I did that, didn't I? And this is what I got. That's a derivative. That's not a slope, right? What else do I need to find the slope? The y value. Yeah, that's where implicit's a little different. Because x's and y's are married together, you need both. You don't need just the x. If it was an equation like this, you would just need the x, plug it in, and solve for y, right? You would take the derivative of that, plug in x value, you get a number. But that's where these guys are different, because x's and y's are married together. They're stuck together. So we can't do it that way. We have to find y first. Okay? So I have to find y first. How do I find y1? Not set it equal to 1. I'm going to do something. What do I have to do? Plug in 1 to the original. Yep. Plug in 1 to the original. Look at the original. The original has an x and a y. So if I plug in x, I can solve for y. That's what I want, right? So let's do that. Let's plug in 1 to the original. Anywhere I see an x, I'm going to plug in a 1. So I get negative y squared plus 6 equals 1. No, not 6, plus 5. Then I'm going to subtract 5 from both sides. Then I'm going to divide by negative 1. And I get y squared equals 4. How do I get y by itself? Square root. Anytime I'm solving and I take a square root, what's going to happen? There's going to be 2 answers, yeah. One's going to be a positive 2, one's going to be a negative 2. Because positive 2 times positive 2 makes 4. Negative 2 times negative 2 makes 4. There's 2 answers. So I have 2 answers. So I have 2 y values. So that's why the question said find the equations. You see the equations. We didn't catch that the first time, right? There's more than one equation. So the first one is going to have a positive 2 up there. The second one is going to have a negative 2 there. Which makes it positive. There's going to be 2 answers. There's going to be 2 equations. Now we got to find slope. How do I find slope? We've already plugged in x, right? I plugged in x early, right? Now we got to plug in y. So I'm going to plug in dy dx, and I'm going to plug in positive 2 and negative 2. First, I'll do positive 2. So I get 4 minus 5 over negative 4. Negative 1 over negative 4, which is 1/4. That slope goes with the top one. Nope. That slope goes with the top one. Because I plugged in 2. Now I got to plug in negative 2. Now I got to plug in negative 2. So I get 4 minus 5 over positive 4, negative 1 over 4. Okay, so this guy would have 2 equations. How can it have 2 equations of a tangent line? How can it have 2 tangent lines at one x value? I'll give you a hint. Let's go back to this picture here. Let's say at 2. X equals 2 there, x equals 2 there. It's going to have 2 different tangent lines. It's going to have one here and one here. Right? 2 different tangent lines. They're not functions. Okay? Anything that's not a function will have that. If it is a function, it only has one tangent line. But sometimes implicit are non-functions. Okay? All right, so I want you to do number 8 now. Same thing. Find the slope. So you're only having to find dy dx. You're only having to find dy dx on this guy. Okay? Okay, so I found the derivative. Okay. Then it said they want me to find dy dx. That's the slope. They want me to find the slope of the tangent line at 2, negative 1. So I plugged in 2, negative 1 after that. 2 for x, negative 1 for y. And that's where I stopped. What do I got to do now? Yeah, that's what we did. We've been doing, right? It says, didn't the question say find that guy? If you're trying to find it, you have to isolate it. So now I have to isolate. Okay. So anything without a dy dx, I'm going to move to one side. Anything with the dy dx, I'm going to move to the other side. So I'm going to subtract 2 from both sides. And I'm going to add 2 dy dx. Okay. So I get 3 dy dx plus 2 dy dx equals 4 minus 2. Well, 4 minus 2 is just 2. Okay. Both of these guys have a dy dx. Factor out a dy dx. That leaves a 3 plus 2. Divide by that. dy dx equals 2 over 3 plus 2, which is 5. There you go. Dy dx equals 2/5. Well, how'd you do it? How did you do it?
So I did find the derivative, but I continued to simplify a little bit more, and then once I got dy over dx, and then I plugged it.
So yeah, from here, there's two ways. You can do the way I did, plug in early and solve later, or you can solve first and plug in later. It doesn't matter which one you do, you'll get the same answer. So I could have solved this guy for dy dx. I could have subtracted 2 from both sides, subtracted 2y dy dx. I could have done that and done all that first and then plugged in, or you can do what I did, was plug in and then solve. It doesn't matter which one you do. It doesn't matter. You'll get the same answer. Okay? Those steps are interchangeable. Okay? All right, so what I want you to do now is do 9a. 9a, they actually give you a picture. So the graph is this guy right there. That's what this guy would look like. Okay? So what I want you to do is do 9a, do 9b with the tangent line. Normal line we've never talked about. I'll do that one with you guys. So don't worry about normal for right now. What is a normal line? We'll talk about that. But I want you to do the tangent line and the derivative part A. So do part A and part of part B. Okay, so I found dy dx, negative 3x squared plus 6y over negative 6x plus 3y squared. Okay, that's A. Now I have to find the equation of the tangent line. Well, they give me 2 points already. They said 4/3 and 8/3. Okay. So I just have to find the slope now. So I'm going to plug in those two into dy dx. So dy dx for 4/3, 8/3 is going to be negative 3 times 4/3 squared plus 6 times 8/3 over negative 6 times 4/3 plus 3 times 8/3 squared. Okay, so I got to square those first. A lot of these things are going to kind of simplify, like the 6 and the 3. That's going to turn to a 1. That's going to turn into a 2. Same thing here. So you can kind of simplify some of this stuff. So I'm going to have negative 3 times 16/9. If I square 4/3, it's just 16/9. You square the top, square the bottom. Plus 2 times 8, which is 16. The bottom is negative 2 times 4, which is negative 8. Plus 3 times 64/9. If you square a fraction, you just square the top, you square the bottom. Still a fraction. Okay, I can simplify a little bit more here. This becomes a 3. This becomes a negative 1. This becomes a 3. This becomes a positive 1. So I get negative 16/3 plus 16 over negative 8 plus 64/3. Okay. Common denominators. The common denominator is going to be 3. So 48, or 16 times 3 is 48. So 48/3 24 thirds. Okay. You have a fraction divided by a fraction. How do we divide fractions? What's the rules for dividing fractions? Multiply by the reciprocal of the bottom or the second. So take the first one, change to multiplication, and then the reciprocal of the second. So we get 32 over 40, which reduces to 4/5. Again, that was a whole lot of not calculus. That wasn't even algebra. That was just more basic stuff. Just multiplying, adding, subtracting. You got a little bit of fractions, but it's just fraction stuff. So 4/5 is there you go. That's the tangent line. We've done that before. Normal line. What the heck is normal line? Normal line is related to tangent line. Normal lines and tangent lines are perpendicular. Normal lines and tangent lines are perpendicular. Okay? They're perpendicular lines. What's a perpendicular line? So if I tell you guys a perpendicular line, what does it mean if two lines are perpendicular? Well, what does parallel mean? What is parallel lines? There you go. Two lines going in the same direction never touch. How can they never touch? What's the reason? What's the mathematical reason why they never touch? There you go. Same slope, right? Whatever slope is here, slope is going to be here, right? What are perpendicular then? Do they cross? They do cross. What's special about where they cross? You see perpendicular lines every day. What's special about where they cross? Exactly. Every angle is 90 degrees. So where they cross makes 4 90-degree angles. You see these every day. Dickinson and McKinley are perpendicular lines. Dickinson is a line. McKinley is a line, right? Four-way stops. Anytime most four-way stops or stop signs or stoplights are perpendicular, right? That's how they make them. When they make the grid, that's what they do. Not all of them are. Not all of them are. But yeah. So what's true about their slopes? Obviously, perpendicular lines don't have the same slope. Their slopes are different. Their slopes are what we call opposite reciprocals of each other. Opposite reciprocals of each other. Parallel lines have the same slope. Perpendicular have opposite reciprocal. So when I say opposite reciprocal, what does that mean? What does that mean? Opposite reciprocal. So if I have a number like 4/5, what's the opposite reciprocal of 4/5? You change the sign, that's opposite. Opposite means change the sign, and reciprocal means flip it. Right? So if I have a slope of 4/5, the normal line is going to have a slope of -5/4. -5/4. Everything else is going to be exactly the same. I don't have to solve for anything. That's the nice thing. I've already done my solving. The normal line is going to have the same point. The slope is going to be opposite reciprocal. That's it. So normal, so if they ask you for a normal, find the normal line or find the slope of the normal line, you just do the tangent line. You do exactly what you do for tangent. But once you get the slope, you just go opposite reciprocal, opposite reciprocal. Change the sign, flip it. What if I had a slope like this? What if I had a slope of 2? What's the opposite reciprocal of 2? Negative 1/2. Yeah, negative 1/2. Good. Okay. So those green lines there, those green lines are tangent lines, right? They're tangent lines. Normal would look like this. Normal would look like that. Cut it. That's probably not a good one. They would cross through the green and the dot at one spot, but it wouldn't be tangent. It would be perpendicular to that's what a normal line is. That's what a normal line is. Okay. All right. Okay. Let's see what time we got. We got about 5 minutes. Yeah, let's stop right there. Let's stop right there. So we're going to finish this tomorrow. And then I have a little activity for you guys to practice on. It's not going to be a Delta Math activity. It's going to be a little activity based on doing practice. So I want you guys to do practice on this, but I want you guys to it'll be a little activity we have. So tomorrow, first thing, we got to finish. Okay, so we're going to finish the notes. There's a couple more problems left, a couple more things to tackle, and then that's all we're going to do. We're not going to do anything more new. Implicit's all we're going to cover this week. Okay, we're not going to do anything new. We'll wait till after the break to cover anything else. Okay?